You're watching the New Stack Makers, a podcast for people who develop, deploy, and manage at-scale software. For more information and articles about at-scale technologies, please visit thenewstack.io. Now enjoy the show.
VMware Cloud Foundation is a private cloud platform with built-in Kubernetes runtime and self-service access to run apps built with both virtual machines and containers. Simplify infrastructure, reduce cost and complexity, and boost efficiency. One platform, one operating model for all workloads.
Hey everyone, we're here to talk to Paul Turner with VMware, and Paul is Vice President of Products for the VMware Cloud Foundation division with Broadcom. And our topic today is VMware on Kubernetes, running virtualized infrastructure, VM-based apps that run on it, the complexities that come with running virtualization on Kubernetes, Kubernetes complexity overall. Hey, Paul, how are you?
I'm really well, Alex, and it sounds like you're in a good humor today.
Yes, I am, and you as well. This is a good conversation to have. You know, we've covered Kubernetes community for more than 10 years now, and it's so complex. Kubernetes has numerous components. It has all sorts of abstractions and configuration options. There's a steep learning curve to understand pods, to understand deployment services, rollback access control. There's so much to it. And then when you have virtualization on top of that, it just adds another layer of complexity. How do you think about this complexity that users face these days?
Yeah, so I think it's a big challenge that we're actually hearing from our customers, more importantly from the Kubernetes community. I'll just kind of give you a stat. It actually came from the CNCF survey that they did in 2023. But 84% of customers, of course, and orgs are evaluating or deploying Kubernetes, and we see that too. It's got the great benefits of automation, desired state way of managing infrastructure, cluster API and services like that you can build around that. And you can really build out a much better platform organization and deployment of services inside your organization. But another stat that came from that, which I think is interesting, is 46% of orgs lack the training and find that complexity is the biggest challenge. And one of the problems is to actually use Kubernetes. It's not just about a Kubernetes runtime. It's about a Kubernetes runtime, and then you need to have the networking integration, the storage integration. You need to have a backup service. You need to have Prometheus, a monitoring service. You, of course, need to have a registry service. You need to have an Istio service set up. And so the problem is that to make a usable Kubernetes, you actually need to go beyond just a Kubernetes runtime. You actually need to have a Kubernetes platform. You need to have a set of services that just are running. And the problem is that turns back onto who? The developer, one of the most expensive resources, who spend a lot of their time actually on running infrastructure services, which should just be there. And when you look at something like running up on a cloud service, that's the way it is. If I want to run up on EKS, the services are there for me. And that's the way it should be for all of our customers. And that's what we believe.
But there's still all sorts of complexities that come with it, and it has given rise to platform engineering in many ways, and how platform engineering is supposed to play that role where it's supposed to help remove some of that complexity. Is platform engineering not working?
Oh, platform engineering does work, but platform engineering, much easier if platform engineering can actually have a service where they go in, and this is what we're made possible with actually VMware Kubernetes service. So VMware Kubernetes service, inside in the box, part of the platform, you actually get the ability, and you do this in your definition, in your spec that you want to actually deploy for the platform. You get your controller runtime, your Harbor registry, your Valero backup service, your Envoy and Antria based kind of network management. You get your CSIs for storage. Everything is, and Istio and Harbor as a registry service, all of those configured out of box. And so you get this very easy platform experience where you actually set the desired spec of actually what you need for running that platform and the different services that you have. And you don't need to maintain those open source bits. It's all done for you. It's all part of what we deliver. This is the new vSphere. This is VCF. VCF delivers this platform where you can deliver VMs and containers as part of one, but you also can decide what are all the container and runtime services that I need for Kubernetes, and just spec out those that I need to have as a platform engineering team and spend more time then on running my services.
So how is the single platform that you offer essentially an extension of the vSphere experience?
No, it's kind of neat. So first, at the underlying it, we've got to manage hosts and server and hardware and physical devices. That's what virtualization does. Virtualization abstracts the physical devices. We abstract the infrastructure, which means the compute, the storage, the networking, and any of the services associated with them. And so everything's based on that. So we virtualize everything. VCF is a platform that virtualizes all of the core compute services. But what we've done is built in then a native Kubernetes into the platform and all of the services that I mentioned. So all of those are effectively how I render IaaS services directly to application users so they can use them, including a load balancer service, including your network management services, including, if you need to, your firewall services. All of those are available then directly out of the box. And so it's very easy. The same administrators who've been running your VM and your platform for running system servers for virtualization actually are now able to run the platform that runs natively containers, CNCF compliant container runtime and Kubernetes based runtime. But they can run it. The same platform engineering team can deploy that as their virtual machine infrastructure. And so it's very easy. It's out of box. We maintain the open source for you. We maintain versions and version upgrades and support updates for them. We keep up to date with upstream Kubernetes. So a lot of the burden is taken away from the kind of core platform engineering team.
So you are managing that inherent Kubernetes complexity and then the added complexity of the virtualization layer on top.
It's not an added complexity of the virtualization layer. I'm not sure where you see the added complexity of the virtualization layer. The virtualization layer actually helps reduce complexity. In fact, if you take the 25 years of IT, I think IT has vastly simplified because of virtualization over the last 25 years. What we're really doing is simplifying the way that you deliver IaaS services through Kubernetes, through desired state kind of management that you do in Kubernetes, through GitOps-led management, and doing that as part of the base platform that everybody knows and loves and have been working in for a long time.
I hear what you're saying. I mean, I'm thinking of managing, thinking about how you manage the different management interfaces and the Kubernetes management tools, and how you think about the troubleshooting. So when issues arise, and understanding the Kubernetes layer understanding the Kubernetes layer and the VM layer that's integrated with it, and how that can lead to what you're talking about earlier is the training issues you have. There's configuration complexities too. I mean, you mentioned how you guys take a lot of care into helping manage those things, but there still are a lot of configuration challenge that come with any kind of any kind of abstraction.
Yeah. But I think if you take just like Kubernetes kind of deployment and the set of services that you actually want to run with Kubernetes, you do that by a set of policies in the way that you configure it with our VCF deployment. And so you just set your kind of policies, and you may set a policy that I actually want to have a distributed Kubernetes control node with a minimum of 3 hosts. I want to maintain that availability. I want to have these sets of services running. You do that basically as a policy spec that you need to deploy. And then every time that you actually roll out clusters to your clients, they can actually do that as this is the policy spec that I wanted to apply to. And so it's a fully multi-tenanted platform. You can provide it out to different tenant groups or different application teams. You can have different policies defined for different application teams so they can get kind of a customized IaaS layer that's specific to them with the set of services they need. So we've done a lot to make this kind of the new platform. I like to call it the new vSphere. VCF is the new vSphere, but it's a much simpler platform for delivering the services that you need as part of it. And you mentioned a couple of times, I'm just going to hit it on the head, right? You mentioned virtualization and the complexity of virtualization. I'll give you just a stat on virtualization, people seem to have this funny belief that virtualization has a significant overhead. Virtualization does not have a significant overhead. In fact, we just released MLPerf benchmarks that actually run on Kubernetes. There are container-based applications that we're running for doing all of the Gen AI-based applications, and MLPerf is a public benchmark. But we did that with Dell and Lenovo, and we were seeing no significant drop off with full virtualization. Most of the time, we were running at exactly the same as bare metal. If you average it across all the benchmarks, we run a 98.3% of bare metal performance, and you get all the benefits of being able to dynamically move applications and pods across clusters to be able to have a standardized way of running your servers and services. So you get all the benefits without the negligible overhead. So it's pretty cool to see.
I think it's testimony to all hard work in how you've provided a virtualization environment that actually can be managed pretty effectively. And now with the rise of platform engineering, that complexity hopefully will continue to decrease. And there's lots of issues that are just inherent to managing infrastructure software. There's memory overhead, right? You need to think about how you allocate memory to VMs and to the hypervisor. You need to think about just things that might come up, like how do you use your resources effectively? How do you think about storage? Your storage environment, and how you get directed access to storage subsystems in a containerized environment. So these are just kind of these are all the things that I think are just probably pretty interesting to our audience. And how did you go about kind of solving these issues? How do you go about solving the complexities that come with these problems? How do you think about these issues that relate to just the inherent complexity that comes with infrastructure management?
Yeah, well, when it comes down to let's talk core infrastructure and take systems, drivers, all of those physical things that need to get done, all of the benefits you had in virtualization matter, which means you just are able to do those totally non-disruptive to applications, non-disruptive to your container apps, and you're able to continue running services. That in itself is a huge gain. You don't have to be beholden to, the 5% average failure rate, annual failure rate that you get off a server. So those kind of things are particularly nice. I think the other aspect of the services is you look at all of these services. This is, on average with Kubernetes, I don't know, 9, 10 services that you need for a platform engineering team to be effective. And every one of those are a different open source module or different module that they may have taken from different vendors, and trying to pull those into your desired platform state, which is your policy layer that you need to deploy on it, is complex, way more so than it needs to be. And I think that change, we think this is why Kubernetes is brilliant. It's brilliant because you can actually go and deploy applications in a much more consistent way. You can deploy them at scale. You can have the applications actually define, whether it's with cluster API or others, but you define the infrastructure state that you want. But the amount of groundwork that you have to do before you get to the fun stuff of just putting these pieces in place is what we're trying to remove. That complexity removal, it's what we've always been good at. How do we remove complexity? How do we make things dead simple? We're going to do that, and we're doing that for Kubernetes. And we've done it actually in 5.2. So the current release that we've shipped, we make it even easier with our upcoming 9.0 release that we're just about to do.
What would you highlight as an example of that decreased complexity in 5.2?
Yeah, so I would say, just again, it's the out-of-box nature of these things, right? To bring on a Harbor service, you actually first Harbor is actually inbox, so you basically can just select Harbor service that actually want to enable as I deploy a cluster. Deploying a Kubernetes cluster is a matter of, as part of the cluster spec, you actually just define it as being a Kubernetes-ready cluster. And you set the policy of what you want in terms of single node Kubernetes or multi-node Kubernetes. And it's all done for you. And so in there is your integration that you may need in terms of, if you want a Prometheus monitoring service, very simple for you to bring that package down and actually then make that package available to every Kubernetes instance or cluster instance that you have available. And of course, the multi-cluster management. Customers need the ability to actually be able to manage clustered applications that actually are even across region, across site, across multi-instances. So the most recent change we made is we took our Tanzu Mission Control, which was basically the central management platform or the multi-cluster management. That is now available to all customers who are VCF customers. So they get the ability to do the multi-cluster management, manage their applications centrally. They can deploy them out to different VCF instances across different regions as they define. All of that is available to the VCF customer. So
I think that, yeah. There's a lot there, isn't there? Yeah.
There's a lot there. The other thing that we do actually that I think was a very important one is we support multiple versions of Kubernetes. So Kubernetes is one of the big problems. I don't know whether they're ever going to fix it in CNCF, but you run a limited duration of support for Kubernetes releases, right? They basically are a year and 4 months or something like that for the duration of a Kubernetes release, which means you're in this kind of continuous chain of updating Kubernetes releases. So the important thing is that then customers have to be able to have multiple versions of Kubernetes. Their applications may use different versions or be validated with different versions of Kubernetes. Our service always ships with a running set of 4 or 5 versions of Kubernetes. And so you can actually have different application sets using different Kubernetes runtimes, all perfectly fine. And we provide full support for all of the components that we ship.
So one of the things I'd like to talk about before we talk about the innovation that we're seeing in the Kubernetes community and how you're contributing to that innovation, I'm curious about, how you're thinking about private AI, right? And how you think about how that intersects with Kubernetes. The data story now is much deeper part of the story overall that we're hearing, in the pages of the news stack and and just in the larger community. And what's the intersection there for you between private AI and Kubernetes?
Yeah, so private AI. It's actually very interesting to see that many customers are looking at they need to run AI applications to help enable their businesses, and those AI applications are generally container-based, Kubernetes-based applications because we're building out a sort of application set. And whether you go to a partner of ours, right, Nvidia, and you go to NGC to their GPU cloud, you're going to pull down container-ready images that are actually going to be your part of your application set that you're going to use for actually your AI learning and your AI training and your inferencing service or your inferencing runtime that you want to have. So Kubernetes is a core to this. In fact, I would say AI is probably driving almost half the deployments of Kubernetes out there, AI-ready applications. So the fact that this platform actually is Kubernetes ready and very easy to kind of set up and establish makes that very easy. I think the second is, you mentioned private AI. We're seeing this in spades. Many customers, there's really a choice. They can run up on a cloud service and do generative AI up on one of the public cloud services, Azure, Google, or other kind of services like that. Or they can actually look at their data, think of the sovereignty of their data and the trustworthiness of the data, and they want to be able to run those same AI applications that they could run in the cloud and take, NGC services that they want to be able to run. And they want to be able to take those open source models, the Hugging Face models, the Llama models that they may get, and be able to run AI applications on them. And that requires a platform that can support it. It requires, as you said, storage platform with high streaming throughput and performance to it, very high bandwidth networking interfaces that can support it. It requires a container runtime, but actually a full Kubernetes runtime, which is all the services that I mentioned earlier. All of those things are needed to actually run an AI service, because that's what you're trying to do when you do private AI. You're trying to run an AI service inside in your company. And that's what you can do. And we work not just with NVIDIA, we also have worked with the open source community. So we work with the OPIA team, which is an open source framework that Intel are part of, AMD are part of, we are part of. We actually just recently sponsored a UC Berkeley project on doing some more open source. There's a significant announcement we just made with them to actually do more research into AI, open source AI applications. So we see this intersection between Kubernetes and container runtime running on our platform services and the private AI services that customers want to enable to.
And so when you're thinking about, this private AI story and, and a virtualized environment, um, what are the opportunities there that you would see for, for customers? Because AI is, as we well know, it's performance intensive on everybody, right? And it's also technically challenging. I mean, you need to have people who understand VMware. You need to have people who understand Kubernetes, and now you need to have some knowledge about AI ML technologies and their frameworks. And so there's a lot of combined discussions here, but I'm curious on how you guys, view that because the opportunities are clear with AI, but I'm wondering if the overhead and complexities right now negate that a bit.
No. I think we make it. So we've made Kubernetes. Hopefully you believe it. We've made Kubernetes very easy to use out of box. All the services that you need. We also do the same thing with private AI. We have something called Private AI Foundation. Private AI Foundation basically brings in the ability to basically run out of box all your NGC or your Nvidia GPU cloud services. We've got our own, we've extended actually the registry service so that you can actually bring it down as a model registry. So you can take open source models, you can have those as prescribed models that you share inside in your registry service. You then can take in any of the application runtimes that you need. So if you not just are you bound to like NGC stuff, you could actually take open source models and capabilities that you want to bring down into the platform. And also for the user, most of the time they are running, a PyTorch level kind of application, and they need a set of services. So that set of services looks exactly the same to the end user. What we've done is just made it all the infrastructure underneath kind of melt away. So you don't need to worry about it. You just need to run the services, and that's what Private AI Foundation actually helps do. So we released that product about a year ago. It's actually doing quite well in the market, and we hope to see continued kind of strength on that. And I think we will see continued strength, particularly as the problem that I think customers are having is GPUs are not cheap. GPUs have the same problem of that started with CPU virtualization 25 years ago. GPUs are, from anywhere from $30,000 for an enterprise GPU, $30,000 to $80,000 for a GPU. Server may run, $300,000-$400,000 for that server. You do not want to be running that server at 20% utilization. You want to be running that server at 50, 60, 70% utilization. And to do that, you must virtualize. And if you take virtualization of GPUs, you probably remember vMotion for CPUs. Well, we actually just did our testing for 9.0 GPU vMotion. We can do completely non-disruptive vMotion of AI applications running PyTorch front ends. We can move them across servers. We can do that without any disruption. Everything works. And that's with a 70 billion parameter Llama model running inferencing service at the same time.
And
now,
that's
cool.
Yeah. And you have said that, your studies have shown that workloads in VMware and Nvidia platform can, offer performance that's, similar or sometimes even better than bare metal. So
yeah, exactly. You get the benefits of you get the benefits of better than bare metal or the same as bare metal with basically no overhead, as I mentioned earlier. So no significant overhead, but you do get the benefits of, hey, I can vMotion stuff around. Hey, I can actually densify. I can actually have more tenants using those same expensive GPU resources, get up the utilization, reduce the cost. I mean, everything that we've always been known for is the same again for AI.
what's the pre-configuration capabilities that you see coming with VMware Private AI Foundation, such as you know virtual machines that work in deep learning environments?
Yeah. So you may not have seen this, but we actually ship effectively VM ready machines that basically have AI ready applications. So it not just has that, it has the associated GPU drivers that you need to enable. There's a set of services that you need enabled as part of the VM. They're all done under the covers. So everything is auto configured. They run effectively as I said, they're all container-based applications. So they're running the Kubernetes stack under the covers, but you don't even need to know. It's just all done for you. So I think we've made a big effort to kind of make that simple. If you take anything out of this, it's simplicity and then driving efficiency. Some things have not changed in VMware. And those two themes, I think, override everything else in our roadmap. They're about how do we make things simple? How do we make it more efficient? How do we drive more cost-effective uses of resources that you have? And Kubernetes is a good example of complexity overload that we're trying to solve. AI is a good example of underutilized hardware that we're trying to solve. And I think we've done both.
So tell me then about how vSphere fits in from an open source perspective in your work with Kubernetes, and how that will extend into the realm of AI.
Yeah,
Private
well,
AI.
people may not know all of the background of us, but we've been a top 3 contributor in Kubernetes, and we continue to focus on open source Kubernetes, and we're a member in CNCF. But if you take some of the kind of areas and projects that we led, right? Harbor is led by VMware, Antrea, Envoy. We are founding members of many of the core projects that you know. We're active on the cluster API work. We're active still on Harbor, on Valero, on Contour, the Salt service, which is used a configuration service. So open source has been always close to VMware. Open source remains a commitment from us as VMware. As we work, we want the Kubernetes capability to remain open, standards-based, available across any ecosystem. We want it to be that application layer that our customers and any customer can rely on as a cloud independent layer. And that's what we think Kubernetes is. That's what it allows you to deliver. We need to make sure it stays that way in our view.
So just in finale, I'd love to hear about how people can get more involved or learn more about your community and how you provide learning. I know there's VMUG.
Yeah. Actually, well, VMUG's probably one of the best. So maybe people don't know the size of the VMUG community. VMUG's 120,000 member community worldwide. We actually have got very involved with them recently to actually drive much more active engagement to that community. So find out where your local VMUG chapter is. You're going to find that there's events happening all the time. Think of them as like effectively meetups. They're meetups and learn events. Become the technical expert. That would be my best path recommended for you. We do, of course, have Explore coming up. We've got that coming up in Vegas in August. If anybody can make it there, that would be great. Keep an eye out. Just go check on our website, vmware.com, and you'll see that we've got a number of open, kind of webinars that you can sign up for all of those people who are customers. So anybody who's a VCF customer, you actually get access. All training is free. Everything online, all of the training, all the services, everything's available for you for free. If you want to become a certified expert, you can actually go sign up at our VMware site. And as part of getting a VMware site and a registration there, you'll also get free licenses. So you get the ability to use the licenses for your developer use. So you can become an expert. You can use the software. You can use it in your home labs. You can build it out. You can continue to build in your expertise. You can get those credentials on your name. And we're going to make it dead easy so that you can do that at scale and do incredibly well as an admin team driving this.
Well, Paul, I've enjoyed your cheeriness in this discussion here. It's infectious. So thank you so much for your time and discussing VMware and being so clear on the value you see in it. And thank you so much for providing this explanation. It's been very helpful.
Yeah, no, great to catch up, Alex. And I need to get on my bike. This background is South Bay, and there's a really nice bike trail that goes all along the south of the bay. So I'll get out there later on.
Well, enjoy the ride.
Will do.
If you like this video, please give us a thumbs up. And if you'd like to see more videos like this, you can always subscribe to our YouTube channel. We're on all the major social media platforms. You can always find us at thenewstack.io. We hope to see you soon.